Hey guys, we're going to continue with the law of cosines today. Last video we derived where it came from, and this one we're going to actually solve a triangle using the law of cosines. So let's say we had a triangle, and I'm just going to do an arbitrary triangle, A, B, C, and I don't know, 16, 24, and 20. This isn't going to be a right triangle. I know because 16 squared is 256, 20 squared is 400. So if you add those up together, that is 656, and 24 squared is 576. So a squared plus b squared does not equal c squared, so it's definitely not a right triangle. Now, this case, we're given all three sides. If you're given all three sides, if we look at our law of sines, that's not going to help us. We would have A, B, and C, but if we were just working with either of or any of the three equations you can make, just say sine of A over A equals sine of B over B, you would only have two unknowns filled in. If you did these two, only two unknowns filled in. If you did those two, only two unknowns filled in. So you'd still have two unknowns to work with, so you wouldn't be able to use the law of sines. Really, anytime you can't get a pair of opposites, so either an angle and its opposite side, you're not going to be able to use the law of sines. So in this case, we're not going to be able to use the law of sines. So we're going to have to use the law of cosines. So we have sides A, B, and C, and we'll just be able to use these laws. Now, when you have all three side lengths, what's nice is you can choose whichever one you want to work with. So you can choose which angle you want to find first. Personally, I always like to find the biggest angle. The reason I like to find the biggest angle is this gets rid of something that we're not actually going to deal with, and I'm not going to give you problems that involve it, but it's called the ambiguous case, where the same pieces of information can give you two different triangles. So to avoid that, when you're using the law of cosines, if I can, I always find the biggest angle first. So if we look at this triangle, we have side lengths of A, B, and C. The biggest one is B, so that means this is going to be the biggest angle. Angle B is going to be the biggest angle. So what I'm going to do is I'm going to be using the one B squared equals A squared plus C squared. Oops. Start to write the square first. C squared minus 2AC cosine of B. So we'll use this equation and we'll try and solve it. So with that triangle, side B was 24. So it's 24 squared equals A squared plus C squared minus 2 times A times C. Oops, getting a little ahead of myself, multiplying by 2 beforehand. Times the cosine of B. The only thing we don't know is that angle B. So now it's just algebra to isolate this whole cosine of B. We're going to want to get that whole cosine of B by itself. And then we'll be able to use cosine inverse on our calculator. So 24 squared is 576. 16 squared is 256. 400. Oops, not equals. Minus. And then that's 40 times 16 is 640. Cosine of B. So 256 and 400 is, 656. All right, here is the trap that kids fall into all the time. right here. This does not simplify to 16 cosine of b. It does not. These are not like terms. You cannot combine them. This one has the cosine of b. This one does not have the cosine of b. You cannot subtract these two. If you do, you're doing it wrong. And then you would have 576 over 16, which you're not going to be able to take the cosine inverse of. So first we subtract 656. So that's negative 80 equals negative 640 cosine of b. Divide by negative 640. And cosine of b equals negative divided by negative is positive. 8 over 64 is 1/8. So cosine of b equals 1/8. So that means angle B is cosine inverse of 1/8. I'm not expecting you guys to know what that is off the top of your head. And I'm also going to use my calculator. So I did cosine inverse of 1/8 and got 82.8. All right, so 82.8. So that's angle B. So I'm going to go back to my original triangle, and I'm just going to label that on my triangle. 82.8. So from here, now we have 4 pieces of information. We could use the law of sines, because now we have a pair of opposites. Or we could use the law of cosines again. Now, normally, I would use the law of sines. What I would set up is sine of b over b. So sine of 82.8 over 24 equals, and then I'm going to find a, sine of a over 20, and then solve this equation. But I'm not going to do that this time, just because we're practicing with the law of cosines. All right? You can do it this way, and then you'd find angle A, and then obviously angles A, B, and C add up to 180, so you wouldn't need to use trig to find the last angle. But instead, to find angle A, I'm going to use the law of cosines again. I'm going to use this version right here. A squared equals b squared plus c squared minus 2bc cosine of A. So 20 squared equals 16 squared plus 24 squared minus 2 times 16 times 24 times cosine of A. So we know some of this all right. 20 squared is 400, 16 squared is 256, 24 squared is 576, and then 32 times 24 is 768. So we combine our like terms again. So 256 and 576 gives us 832. Again, these are not like terms. You cannot combine these. Don't fall into that trap. So we're going to subtract 832. So that's negative 432 equals negative 768 cosine of A. Divide by negative 768. So negative divided by negative is positive. I'm not going to simplify this one just because it's not as obvious as last time. It wasn't 8 going into 64. And I'm just going to be using my calculator anyway to do A equals cosine inverse of 432 over 768. Which is not something I expect you guys to know. So cosine inverse of 432 divided by 768 is 55.8. So A equals 55.8 degrees. So we've got angles A, we've got angle B. So angle A is 55.8 degrees. And for angle C, we have two angles. Subtract them from 180. 180 minus 55.8 minus 82.8 leaves us with 41.4. All right. So that's solving a triangle using the law of cosines when you have all three sides. All right, have fun.